The singularity of a black hole is a point at the center of the black hole where the laws of physics as we know them break down. At this point, the gravitational field becomes infinitely strong and the curvature of spacetime becomes infinite, which makes it impossible to describe the physics of the singularity using the laws of general relativity. This is known as a mathematical singularity, and it is related to the concept of asymptotes in mathematics. An asymptote is a straight line that a curve approaches but never touches. In the case of a mathematical singularity, the curve is the spacetime geometry of the black hole, and the asymptote is the point at which the curvature becomes infinite. In other words, the curvature of spacetime becomes infinitely steep as you approach the singularity, but it never quite reaches infinity. This concept can be illustrated by considering the Schwarzschild metric, which describes the geometry of a non-rotating black hole. The Schwarzschild metric contains a term called the Schwarzschild radius, which is related to the mass of the black hole. As you approach the Schwarzschild radius, the curvature of spacetime becomes stronger and stronger, and it becomes more and more difficult to escape the gravitational pull of the black hole. At the Schwarzschild radius, the gravitational field becomes so strong that nothing, not even light, can escape from the black hole. However, the Schwarzschild metric breaks down at the singularity, because the curvature of spacetime becomes infinitely strong. This means that the physics of the singularity is not described by the laws of general relativity, and it is currently not known what happens at the singularity. One approach to dealing with the singularity of black holes is to try to find a theory of quantum gravity that can describe the behavior of spacetime at the smallest scales. Such a theory would need to combine the principles of general relativity with those of quantum mechanics, and it is an area of active research in theoretical physics. In summary, the singularity of a black hole is a point at the center of the black hole where the laws of physics break down. It is related to the concept of asymptotes in mathematics, because the curvature of spacetime becomes infinitely strong but never quite reaches infinity. The singularity is an area of active research in theoretical physics, and it is hoped that a theory of quantum gravity will one day be able to describe its behavior.